Hi guys, welcome to Learn Electronics Repair. I have another job here from the builders who brought me the industrial cleaner you saw in the previous video. So this one is a battery charger, 30/15 amp. He brought me this in and taped to the wire was this, not in the bag. I've put it in the bag afterwards, so don't worry about what it says on the bag. And he says this is broken off or fell off, okay, or fell out of it. So this is actually either a fuse or the top off a fuse. So it's effectively empty. Looks a bit blackened inside there though. So that has come out of it somewhere, yeah? And that's the problem. Or at least one problem. I don't know what else might be wrong with this. So we have, well, it's mains powered going in, and then it has two terminals. It looks like a car battery charger type thing. Some sort of sensor here, which I'm guessing attaches to the battery. Wurth, so these make tools and such, like flashlight. It has a light built in, or this doesn't. Oh, it even lights up. So yeah, that's what we have. I'm not sure what they use this for. A little bit more information. So Accupower 30/15A. Looks like 15 amps. Let's just loop this model number up and see what it tells us. Yeah, it's a motor vehicle battery charger, so car battery charger I would say. No, 12 or 24 volts. Okay, so cars or trucks. Or something similar like that. I'm not sure how much this thing costs. I can't even be bothered to log in just to find out how much one of these would be. Let's just concentrate on seeing if we can fix it. And while I'm just opening this up, how could that thing have fallen out of it? I mean, I don't see how that could have fallen out. That tells me somebody's been in here, I would say. Maybe heard something rattling, it went in and found that and didn't know what to do about it. He didn't know it was a fuse or the top off a fuse, that's for sure, when he brought the thing in to me. Okay, well, it opens up. It was easy to get into at least. Okay, so this has been sitting here for the best part of a week probably, waiting until I got around to it. So I don't think there's going to be any voltage in this, but let's have a quick look what we have. Well, we have some big capacitor here under this, so that's there. So let's just make sure there isn't any voltage in this. Okay, this is the low voltage end, so this will be fine. So from here to here, no, there's no voltage in it, so it's safe. Okay, right, what do we have? How easy is it to get at it? Well, we can see where the wires come in, and they're soldered directly to the board down there, so it's a bit awkward. This we can remove. Okay, let's see. It wouldn't be so easy to unsolder these. I mean, it wouldn't be so difficult either. This is just the fan, and then this goes to the, this is the mains coming in here. Okay, so that's where that goes. That is the remains of the fuse, so the top has come off that. Okay, evidence of something being blown. There was somebody trying to fix that. Somebody stuck a bit of wire over it. Somebody been at this. Let's see. I'll just mention, guys, just because this blackened area by this fuse. This may not be something I can repair in one session. I may need parts for this, so we should at least be able to diagnose what's going on. What's this here? Oh, okay. This is where the fuse goes, these two pins. Here to here. That reads open. Okay, so it reads open. I think I'm going to unsolder the wires from this so I can actually easier work on it. It's a bit of a pain in the butt trying to work like this. Yeah, these two go into this little vertical PCB here. It's a bit awkward to get at, actually. I'm not sure if maybe I can just release the strain relief grip on this actually and get it out. No, because this is all glued, so that's not going to be easy either. Oh. You know, guys, because of where that is, and I really want to get this cover off here, I think I may just end up cutting the wires, and then I can always put a heat shrink back on and solder them again. I'm really not totally convinced I can easily get this out of here. Unless I get the whole board out, there's something else on it here. And then that's soldered to there. No. Let's not go that way, yeah. Let's not go down that route. So these are obviously covered in some sort of heat shrink anyway for some reason. I'm just thinking, can I unsolder them easily from this side? Let's give it a go. We can get in down here, get enough heat in. Yeah, okay. This one. Same. Take this off here. Okay. Now it's coming out a bit more. We can see this is the NTC, which is on the end of that wire. Okay. I should be able to unsolder these and resolder them. I have a good chunky soldering iron, so I think it's just going to make this easier to work on. Let me know down there what you think, guys. A mixture of hot air and solder. Okay, so that's it. This is where the NTC was connected here and here. This one here actually connects also to here. Anyway, and this one actually connects to the battery miners, which we can say is ground. Okay, so that's where that was connected. This is where the fan was connected under here. In fact, it says fan. Just move that out of the way. You can see the two holes, but I put a red dot. This was the red lead, so I know which was which. Okay, mains in, filter, looks like another filter to me, filter inductor, bridge rectifier. That's where the fuse is or was. Okay, there. Fuse is rated, what was it? 3.15 amp. Okay. After the bridge rectifier, the large smoothing capacitor sitting under here. Then we have switching transistors, I would say. There's a couple of transformers here which look identical. Okay, some more transistors, another transformer. Are these inductors? These might just be inductors, these ones. Looks like this is the transformer. Output side, so rectifier diode. Smoothing capacitors, this looks like a relay, yeah, about 14 volts. Another relay there. Some sort of microprocessor or brain. Okay, another chip here. These are probably MOSFETs and probably in parallel on the output, actually. That's what we seem to have. So let's unsolder this fuse, what's left of it. Just while the desoldering tool is warming up, the vacuum tool, where these look like inductors, we have two devices here. Now, I can see that one of them is a diode and one is a MOSFET. So I'm pretty sure this is a PFC. This area. Interesting to have two inductors, but maybe that one's a PFC and maybe this there's some sort of filter on the output. In actual fact, not even vaguely in parallel. Let's have a quick look. Yeah, this seems to be the low voltage side, high voltage side. This is the transformer across the two. That's some sort of, don't know exactly. Okay, I don't know exactly there. Yeah, this seems to come across to this side, but it's also on this side. I'm not exactly sure at the moment, but I think this is PFC because of these two devices. Okay, and now the desoldering gun is warmed up. So let's get this fuse out. Okay, I think it just fell out. Yes, there it is. So let's have a look. I'll give that the benefit of the doubt and say that's the original fuse element. It hasn't been messed with and it's just blown. Okay, I mean really blown. So possibly short circuit somewhere in here, unless the thing was just overloaded due to some sort of user error or faulty battery charge, maybe trying to charge a faulty battery. So let's just check if we see any obvious shorts. So here's the bridge rectifier. Pretty good place to start, I would say. We can see this is where the power comes in. So power comes in here, bridge is here. Multimeter on diode mode. So we should have, you would think, some sort of connection from the power coming in to the AC terminals on the bridge rectifier, which are almost certainly these middle two. Well, that goes to there. Oh, and I see a short. No, I don't. I saw something. Okay. That doesn't go to there. So there's something odd. I'm not saying it's wrong, but something odd here. Let's check the bridge. So the chamfered end, which is this end, should be the positive output. Okay. So red on the AC, black on the positive output. Diode junction, diode junction. Okay, and then black on the AC, red on the negative output. Diode, diode. So it's not a short, and there's not a short there. So what am I seeing across these two? Interesting. Well, it seems reasonable to assume that the fuse is going to be in one of the connections from the mains in to the bridge rectifier. That's the first thing we can say for certain, I would say. So we know this goes to here, and we know this doesn't go to here, but this is where the fuse would be, and that goes to there, and then this goes to here. So that's the fuse. Across the two AC terminals, well, I don't see anything there. But I do see this here. Let's just go to resistance range. Let's have a look. Quite a high resistance. But I don't really initially see why I would see that there. That's going the other way. So there's a capacitor involved somewhere, I would think. So this thing here, yeah, these are the coils here, so these are filters. So the filter appears to be, yeah, this end to this end, this end to this end. Don't see anything across there. That's probably before the fuse. Oh, there's the fuse, so it's after the fuse. Yeah, there to there. This to here. My mistake. So across here, nothing. Nothing. This is in continuity mode. And in diode mode, strange. And of course it'll be across here as well. I don't see why I'm seeing that, to be honest. There's no short across here, so that was reversed across the bridge, this being the positive end, so red to here to here. Oh no, I do see something. Okay, so let's go a bit further. So if this has PFC, and we know it does have, or we should know, because we have a PFC diode here, then we will find that the output from the bridge rectifier does not go directly to the large capacitor. One end will, the negative end, to there, but the positive end goes through a diode, which is the PFC diode. That's a bit of a strange reading. 0.4. See, that's the opposite way around. I'm not happy with the readings I'm having here, guys. Okay. PFC diode. Doesn't go there. I need to think a little bit. Okay, guys. So, PFC. Bridge rectifier, plus minus AC, AC, and we know we have a fuse which is blown, and one of these wires, whichever one, okay, goes into there. We also appear to have some smoothing capacitors, or filters rather, and an inductor or double inductor here. So it's something like inductor, inductor, capacitor, capacitor, bridge. Yeah. And this side reads okay. This side has a strange reading on it, we can see, between the two AC terminals, because if there's no problem over here, this should read open, and it doesn't read open. So with the PFC then, this is hot ground. So normally here you would have a large capacitor or a couple of them in parallel high voltage large capacitors, but with the PFC you don't. So you have an inductor like so, you have a diode like so, Schottky diode or a fast switching diode at least, and then this is where you have your large capacitor, and then this is where it goes into the circuit. Okay, load. In this case the load would be the switch mode power supply. So effectively you would have the primary of your switch mode transformer switching MOSFETs. Okay, and here you have a MOSFET, and this is connected to your PFC controller IC. Okay, so this is switching on and off at very high frequency, which keeps pulling current through this inductor for very short instances, and when the MOSFET switches off, the magnetic field in the inductor collapses, so this end becomes more positive than this end. The rectifier diode rectifies that and it charges the capacitor, and this is a boost circuit, so it boosts the voltage here at this end of the coil by building the magnetic field up and letting it collapse again. This end of the coil is effectively DC, okay, or at least pulse DC. So that's what we have, that's a PFC. Now I shouldn't read the short across here, and in fact in the forward direction, drain to source, I shouldn't really read anything here. This should read open basically. There may be some high value resistor somewhere, but that's what it should read, and it doesn't read open at all. I have a reading across here, and the most likely cause of that is a problem with this diode or a problem with this MOSFET. So let's have a look. So this is the bridge we know about. This is the large capacitor. One of these inductors will be the PFC inductor that I showed you, and we have the diode and the MOSFET here, and I can kind of trace a lot of it through. So in diode mode, which we are, we can see from the negative end of the bridge rectifier to here, this is hot ground. Okay, this negative sign, this is hot ground. From the positive end to hot ground, with this end positive, which is a normal way in which the polarity would be, we see 0.698, and in the reverse we see 0.491. Now this is the diode from here to here, okay, and the other end of the diode here goes to the positive end of the capacitor, and the connection from here to here is via an inductor, and it's not this one, okay, it appears to be this one, okay, certainly a connection there and a connection there, okay, so it appears that's probably the inductor. It comes back round this way. Haven't traced it through, but what I can see is the MOSFET. So PFC MOSFET, gate, drain, source. Okay, almost certainly. So the drain should connect to the positive end of the bridge rectifier, and it does. Okay, and the source should go to hot ground, which it does, so that's the right position in the circuit. If I go positive on the drain, I see that 0.677, and I shouldn't see anything there. In the reverse direction, with a positive on the source, if this is an N-type MOSFET, which I'm confident it will be, we should see the parasitic diode, and I do see it. So it's like there's something in this direction, almost like a diode junction, and that's what's got me thinking there's something wrong here. Yeah, that shouldn't be like that. I'm not sure exactly what it is. This isn't short, but there's something. So I'm going to have to take this out of circuit. If I go from the gate, well, that's reading 1.6, and it should really read open. So let's take this MOSFET out and then let's read in the circuit again. One thing I've just noticed, by the way, is when I went to the screw on here, this one just turns round. Whether that's somebody being in here or whether it's just loose, so the PFC MOSFET isn't against the heatsink properly, I don't know, but assuming it was just loose, that would mean this isn't being cooled properly most likely, and would be a good explanation for the failure. Okay, certainly this is a very strange failure mode for a MOSFET if it is the MOSFET, but there's also something seriously not right in this circuit, or I'm really misunderstanding the layout of this circuit, so I need to investigate anyway. So let's get this MOSFET out. Well, I'm just waiting for the desoldering gun to warm up. There's another possibility here. So if you look across the large capacitor, I'm reading 0.296, and the other way, so this is the normal polarity of operation, I'm reading 296. So there's certainly something wrong here, and it could be the problem is in the switching transistors here, these ones. But let's just get this unsoldered while we're here, since the vacuum tool is now warmed up. In fact, as I was just unsoldering this, it occurred to me that because I see the problem across the capacitor, which is the other side of that diode from this MOSFET, this is almost certainly okay, and this is where the problem is. And I was kind of reading through that diode and I got that strange reading. But anyway, here is my MOSFET 16N50. I think this will read okay for the reasons I just mentioned. Let's see. Yeah. So the MOSFET's good. Let's go a little bit further into this. So the next thing that might be short are these, or one of them, okay? So this L6598D, this will switch these on alternately. This also looks like a standby power supply to me. You see this thing here? Has the look of a standby supply, although I don't quite see what is controlling it, if it is. Well, never mind. L6598D. This is a resonant controller, and this may also be a PFC controller. Let's have a look. Okay, so high voltage resonant controller. If you have a quick look, you'll see this drives two MOSFETs, high side and low side, okay? That's those two MOSFETs which are sitting next to it. This isn't also the PFC controller. There must be another one on the board somewhere for that. Sometimes you get a combined one with PFC as well. But you can see this switches these two MOSFETs, and the load is basically the transformer, the switch mode transformer. We'll probably find a typical application. Yeah, here. So you can see two MOSFETs, an inductor, and the transformer, and some capacitors. This is an LLC bridge, as it's called, okay, or rather LLC half bridge to be technically correct. So what happens is these switch in turn. This one connects to the output. In fact, this is much like our circuit. Look, there's the PFC MOSFET, there's the PFC diode, here's the high side MOSFET, the low side MOSFET. This is the large capacitor, positive end and hot ground. So we already know this is okay. We can check the diode again. I'm pretty sure it will be okay, and we can measure these MOSFETs. So that's why I say this is the next thing in line to be causing a short or a strange low resistance across this capacitor. Yeah. Do you also see why I suddenly realized the problem is across the capacitor? So if this diode is okay, it's not going to be this MOSFET, it's the other side of the diode. That's what I meant. So our MOSFETs, gate, drain, source, gain, drain, source. Oh, look, something fried, something's happened here. You see it? Okay, let's see what we read across the MOSFETs. Well, that one's short, and that one has a strange resistance. That's the funny resistance we could read, because we know they're in series. Look. Okay, let's take these MOSFETs out. Okay, so we can see more clearly now. So this is where the MOSFETs were. That's a little bit of stray metal there. This is the blown component. Okay. We have some either transistors or diode down here. Single or double diodes or transistors. Okay. And then we have the chip. So it may be that these are in the drive circuit to these. So we could have some of these blown. That one, I think it's just reflective, to be honest, just shining on the light. This chip you saw on that schematic drives these pretty much directly usually, so that could also be damaged. We have more devices here. Okay. That connects between drain and source on this one directly. If we can find a similar device, yeah, there. So I'd probably say that that is the same as that, and it looks like a capacitor to me, although it's not really marked. Oh yeah, that one says C44, so we can say that is a capacitor, so we could replace that, I would think. Right, what do we see now? So these are the MOSFETs, 16N50 again. That was the PFC one, so they're all the same. It looks possible that that capacitor has failed and taken at least one of the MOSFETs with it. Maybe. Let's see. Well, that's short. Completely short. Red, green and blue. So that means we're likely to have a problem with the controller IC. This one might read okay. Maybe that capacitor, because it was a strange thing for a MOSFET to fail and give like a reading. Okay, let's see. No, that has failed as well. This capacitor, which is across this one, is that what's reading that funny 300 and something? No, it actually reads open now. That reads open. Now let's have a quick look again around the PFC circuit. So across the capacitor now, we still have a reading, but that's in the negative direction. This is in the normal polarity. Look, it's gone up to open. And across the bridge rectifier now, that's in the opposite direction. This is the positive end. Reads open. Yeah, that's definitely the positive end. Goes to the PFC diode. Goes to here. So that should read open. And does. We don't need to worry about the reading in the opposite polarity, because that never actually happens in circuit. We're just seeing two diodes in series basically in the bridge rectifier, but only in the polarity, which doesn't occur in operation. Okay, so that's what was going on with that. I've just had a look. I don't have 16N50. I will have to order some. But we shouldn't just stop here at the moment. We need to have a look on the output side of this for any short circuits. So first place to look, just across the output. Okay. Again, I see a reading. Let's look at these MOSFETs. So positive to the drain, that to open, that looks okay. Positive to the drain again, that's open, that's okay, probably. So the other things we need to look on this side are the diodes on the output. So these things here with 3 legs on will be double diodes. Yeah, in fact you can see, look, this is the secondary windings going to either end of the diode, and this is the output. Okay, so positive on here should read like a diode. That reads really low. That also reads really low. So does that one. So does that one. These could just be very, very good diodes. Let's go the other way. In fact, this will read like a short because it's the winding. So black here to here. Capacitor charging goes open. Okay, same on this one. So in the reverse direction we see the capacitor's charge goes open. These are probably just extremely good diodes. Let's see if we can see the markings. Have a look for a data sheet. By extremely good I mean a very low forward voltage drop. I have seen, particularly in SMD, so STPS60, it's a bit hard to read, 60L45 by the looks of it. STPS 60L45. Low drop power Schottky rectifier. Note, low drop. Very small conduction losses, negligible switching losses. Okay, so these are just a special type of diode. Okay, center tap Schottky barrier rectifier. Suitable for 5 volt output. Mine isn't 5 volt output, but there we go. 45 volts maximum, that's fine. Okay, so that's what we have there. They read okay. So watch out for these sort of diodes. I've only seen them recently on devices, to be honest, and I've only previously seen them in SMD devices as well, so they obviously do also exist in this type of device. Don't let yourself be fooled that they are short, because they kind of look like they're faulty, yeah, down there. So what's going on amongst this lot? Well, the chip I'm going to change anyway, because I know it directly drives these things. That looks okay. The capacitor, well, we can compare it with that one and figure out what it is. In fact, without the MOSFETs fitted, it's probably quite easy to measure that in circuit. This thing could be diode, could be transistor. Reads like a junction. Yeah, I think this actually might be a diode, you know. Could be a transistor, high over the emitter. Certainly isn't short. It's marked though as D19, so probably is a diode. This one Q, so this is a transistor. I think I can get in under this. Yeah, it's like a transistor junction. And that reads open. Let me just go the other way. Could be a PMP device. Yeah, that's shorted to there. Transistor junction. This one might be short. Just try and get in at it a little bit better than that. So here to here. No, not short. I just couldn't get a good connection onto it without shorting out, basically. Yeah, PNP transistor. Reads open. This says diode. Could just be a single diode. That it does say it's a diode. This one. Looks like a diode or a MOSFET. 47W. A7W. So yeah, that device is the same as that one, and they both measure the same in circuits. So I'm fairly happy with that. Reads like a that's a bit low that way. Reads okay that way. If it is a transistor, don't know, is there a marking on it? It's the same as the other one. A4W, what is this thing? Well, a bit hard to say. So that's an A4W, the same as this one, which is a diode that says D19 by it. We also have another slightly damaged capacitor, or something happened to it there. Okay. Again, I'm sure we can find the same one on the other side of the circuit and figure out what it's supposed to be. So the one I'm concerned about in particular is this one here. I'm not sure what that says on it. It looks like 1T or TT or something. This is the one that's reflecting a lot. Very difficult to read that one. This is a 100 ohm resistor next to it though. That might explain one of the readings we're seeing. So if that strange low reading between what looks like collector base, if it is a transistor, so basically from here to here, that reading, not in that direction, in the other direction, fully enough, so it probably isn't this resistor. That would be the same both ways. You know, 189, what's this read? Very low, but I'm in diode mode. Okay, so it's nothing to do with that. This one I'm a bit dubious about. 2, that looks like a junction to me. Is that a parasitic diode? No, it is saying both ways. Okay, this device I'm really not sure about that one at all, but I'm not even sure what it is. So let's just read across this thing again. That reads open. It also reads open. That actually probably looks okay when it's not under the microscope anyway. Okay, we can change that. We can say with confidence that is the same as this one, and I think we can even measure this in circuit. Now we don't have the MOSFET fitted. Let's have a look. How does it look? Well, actually, how does it look on the multimeter first? Goes open. Okay, so that is a 1 microfarad. How does that burnt looking one read? Does that also read 1 microfarad? No, it reads low, so that one is going to have to come out. This begs a very interesting question though. What the hell is a 1 microfarad capacitor doing connected between the drain and source of a switching MOSFET, a high voltage one at that? Yeah, I mean, this is one end of the component here, and that definitely goes to there, and the other end of it goes to here. And then on this one we can clearly see that this thing is wired across the MOSFET. And we can clearly see on the capacitance meter at least they read different. I mean, on the resistance 941, also reads different. I mean, that could well be that faulty component, but why would there be a capacitor there? It makes no sense to me. At least not a large value one. I mean, we see here C44, so this is a capacitor because the drain source. I can order the MOSFETs. I mean, that's not a problem. I can order MOSFETs. I can also order one of these. I only have the 6599, not 65980. So I can order some of them as well. That's also not a problem. Has this actually got a hole into it? Just no, it's just a bit of crap on it. So it's not got a hole in it, but that does directly drive these. But the problem I have is that I have what looks like could be a Schottky diode. It could be something else down here that has markings I can't really read. But wherever that's connected, you would assume there's a device over here in basically the same position. I mean, I do know one is high side and one is low side, but you would think there would be a similar device here. I mean, we do see more transistors here, but this could be something else. So those two, A4W, A4W. Let's see if this thing here looks like that thing there. I mean, the marking of that is very difficult. It almost looks like an arrow. I know T1, that could be T1. This one looks like it's also fried. In fact, it is fried. Or is it? No, I think it was just something on it. So this one, same sort of effect on it. Very difficult to read. Could be T1 again, or 1T or something. Looks like it is the same as that thing. That is definitely a T1. Now we can see this much better. Let's assume that is also a T1. What did it look like on the multimeter now? Well, we can see this as a transistor Q. I may have measured this before and just forgot what it looked like, so let's try it again. So 1.61, let's go for PMP. .34 climbing. This one lower, and the other way same, pretty much. And this way looks like a junction with the positive here. Looks like a junction with a positive here. Do you know, they look very similar, so I'm gonna take a punt that they are okay. I may well have to unsolder this to find out what that really is. I don't see why we'd have a capacitor across there. Some of you guys, I know you're quite experienced. What's your thought on that component, that capacitor, which is definitely a capacitor in that position? You know, why would we see that? Because I'm a little bit, maybe I need more sleep, but I just can't get my head around that. Maybe 4 AM will do it moment, yeah. Okay, I'm back. It's tomorrow already. Yeah, it's tomorrow already. So I didn't have a 4 AM moment with this. I still can't figure out why there would be a capacitor directly across the MOSFET here. Okay, And in fact, we see the same sort of thing on the PFC MOSFET as well. So there's one here, there's another one here, and then one there. Yeah. So I really don't understand, and I certainly don't understand why that would be a relatively high value like 1 microfarad, because you would assume it was a relatively low voltage in that case. Well, this is quite a large SMD capacitor. They are definitely capacitors, we can see that from the silk screening. So what I decided was to give a better idea whether or not I can actually repair this by changing these MOSFETs, and let's change the controller at the same time, just because we can and it's sensible to do. Yeah, is to take these transistors off, the ones that I can't measure really, I'm not sure exactly what they are, and I can remove this capacitor, and let's have a look to see what value that actually is out of circuit. I can also figure out what size it is as well and make sure I have some of those. Okay, so the easiest way I think to do that is going to be to remove this heatsink first. I don't think I need to unsolder this diode or the bridge. If I take the bolts out, there are just 3 mounting points for the heatsink, and it should come off then. That's the idea. So let's get that removed. We can see this much better now, and to be quite honest, I probably would have had to remove that anyway to change this chip. Yeah, so we can work on this much more easily now. We can see the capacitor now. So this is a 2.2 meg resistor. Another one. The capacitor does definitely connect across the MOSFET. Right, let's remove the damaged one and let's remove this one. I'm just looking at the moment as well, so I don't see the high value resistors here around this. I do around this, but remember, they're not exactly like a matched pair. We have a high side and a low side, so there would be some difference probably. Maybe why we have these additional components here. Okay, easiest way to do this, hot tweezers. Somebody, it was Darren, commented that I don't use stuff that I reviewed in my videos, but I actually use a lot of it. Apart from my vacuum desoldering tool, my hot air station, my T12 and my fluke meter, which I had before the channel, and the little Aneng, but now I've kind of replaced that one with the ZYIE anyway. I think everything else I use here is actually from reviews. Okay, including these. Doesn't want to unsolder easily, so let's add a bit of leaded solder. There's quite some heavy planes in here. I have the tweezers at the moment, they set at 300, so I'm going to turn this up a little bit. $400, give it a bit more. Okay, still add this bit of leaded solder. Okay, now let's try. Yeah, that got it. Come off. And the burnt one. Well, it's actually broke. Half of it came off again anyway. There. There's the other bit. Okay. Oh, my peak component analyzer was not a review sample. That's actually not my original one which I bought. Somebody gave me that as a gift, actually. And my ESR meter and my capacitance meter again were not review samples, nor was my micro ohm meter I occasionally use, but I actually have another one to review, so I'll see how it compares. Anyway, I've just spotted now I actually removed the wrong capacitor there. That's the one which is in the PFC circuit. That may not be the same as this one. This is the one I wanted, so I'm going to put that one back on. Which is very easy with these. And I'm going to take this one off. Again, bit of leaded solder on this end's going to help. I don't want to break this one. Okay. Come off. Right. Oh, come think about it. Well, I'm just getting this out. My Corda 853B hot air preheater. I also bought that myself before I had the channel. There's quite a bit of stuff here which was not review stuff. Is basically stuff that I'd bought before I had the channel. Okay. What does this thing read? Well, it's actually a low value capacitor. This makes more sense. Just quite low. Let's keep going down. 330 picofarads. Okay. 330 picofarads. That makes more sense. Let's see what size that actually is. You could do this with calipers or something, but to be honest, a ruler is probably good enough. So we can see that as 3 millimeters. What's this side of it? Is it 1.5 or something like that? Yeah. It's about 1.8 by 3, something like that. Okay. Let's see if we can figure out what SMD size it actually is. Okay, so I just searched SMD capacitor sizes. I couldn't put resistor because it's standard sizes. According to this, it's probably a 1206. Could be a 1210. It didn't quite measure that much. That 1206 actually looks the same colour. Whether that really tells us anything, I don't know. You see, these are more chunky. So yeah, it's a 1206. So we know what size it is. Let's see if we can find some 330 picofarads, because I'm not sure I've got these. I don't have any. I have some 1206 and some small sizes you can see here. Up to 100 picofarads, and then it goes into nanofarads, so I don't actually have. So I'll add that to the shopping list. Which, funnily enough, I guessed the size. I was right. So, .330 picofarad. Now let's look at these two SMD transistors again. So they looked kind of similar in circuit, but you couldn't say exactly. One had a lower reading than the other. We can just check them now we have the heatsink removed. Okay, so base or gate, that reads too high to be a bipolar if it's NPN. That reads like a diode, and if it was PNP or a P-type, that reads lower than you would expect for a transistor. But there could be something else in circuit that reads like a junction. What do I see across the other two? So if it's PNP, you'd expect the emitter to be more positive than the collector, and it's reading fairly high. Capacitor's charging there. That'll probably go to open in a little while once the capacitor charges up. There's quite a chunky capacitor right next to this, so that's probably what that is. Oh, something interesting happened there. Yeah, fair enough, that's what it did. And the other one, and here's another chunky capacitor, so This read about 0.4, and it reads higher on this one. This one looks very much like a PNP transistor to me. Okay, that is in the polarity it would normally be. And how about the reverse? Yeah, that sort of reads both ways, but again, there's another transistor right next to it. They'll no doubt be interconnected. T1. And I think we can see enough of the marking on this one to say it's probably a T1. It's very hard to tell with that one. But that looks like a 1 to me. I'm not sure I can clean the rest of these up, but let's have a go. No, that really didn't help. T1. T1, my guess. Well, maybe we can get a bit more than that. So, emitter, if it's a bipolar emitter, goes to the collector of that A4W. And emitter goes to collector. This looks like it's connected the same way round to me. So I'm going to say they're both the same and they're both T1. And I'm going to unsolder them and test them. This could be a little bit difficult with this next to it, but easiest way would be to use the hot tweezers again. Let's get this soldering iron in. This is the one with the very bent conical tip, yeah. Let's just get in there. Bit of solder. Bit of flux would have been better, I think. Okay. Let's not make the same mistake on the other one. Okay. Definitely transistor, says Q next to it. Or MOSFET. Okay. This one should come quite easily. I have a bit of space here. Just warm it up. There we go. You see, off it came nicely. Other one, well, capacitor's in the way. Let's see if I can actually get in there. Anyway, not quite so easily, but we'll see. Yeah, I had it, I think. Almost. There we go. Okay, let's check those. Both these, which I've used by the way, were actually review samples again. This one was the cheapest I could find really on AliExpress, which had both C245 and C210 handles, so about €50 or so for the station. This one's a Sugon T26D, which I think has been superseded now, probably by the A9, which I'll still even get one in review actually. And this I also review sample, okay guys. So I've never actually used this one before because I didn't need to, but now I do. So the other option with this would be to solder wires on it, yeah. But with this thing, we should just be able to push down on that, and let's see. So test. Okay, maybe I didn't have it straight that time. I'll position it like that and I'll hold it down with something plastic. Okay, so I can actually see it. Okay. Well, that one disappeared. That was a bad idea. Tiddlywinks. I have one left. Let's see how this one reads. I need to replace that one now. Anyway, I don't know where it went to, so no, guys, don't do that. Do it this way. That's a transistor PNP, okay, so that one reads okay. Can we find the other one? No, I can't, guys. Okay, so nice easy way to test SMD transistors, but don't hold them down with a bit of plastic and play tiddlywinks. Okay, but I think I can probably now find what that is. It's a PNP transistor marked T1. Let's have a look at the SMD code list. Easiest way to do this, SMD code T1, and then in fact somebody's already searched for this thing here already. Let's try that one. Otherwise I would put SOT23, which is a size. There we go. That's NPN. Let's see. Well, we can see the codes used for a few devices, but we can narrow this down. So that's SOT363, that's SOT26, that's EMT6. Only this one is SOT23, which is the size we have. And we can see that it is a PNP transistor. And it's a BCX17. This one, which is like a smaller size of that one, that's a diode. You can see, okay, that's a 6-pin device, 6-pin device, 5-pin device, and now into T10. So even though there's a number of possible devices, we very easily narrowed this one down. So BCX17, and that one is 6598D. Okay, let me have a look on AliExpress and see what I can find. I had a look on AliExpress, I found everything I need. The capacitors came in 1000, 2000 or 3000 volt versions. There was 70 or 80 cents difference, but I just got the 3000 volt version and thought, well, can't really go wrong with that. And the square fuses, I could have just bought one, but in actual fact I can get a whole set of them, so 10 different values. Yeah, you can see them there. So 3.15 amp I have. I don't have any of these square fuses in stock, or maybe an odd one or two, so I thought that was a good idea while I was at it. €5.29, but I'll include that in the cost of parts for this repair. So I have 1000 microfarad 25 volt because I didn't have any, as you noticed earlier on the previous video. I've also ordered the pentalobe screwdriver because I didn't have one. These are the XLR sockets for the speakers I'm waiting for some parts for, and then we have all the parts for this. So I have everything there. I'll get this stuff ordered and then I can get back onto this one. So that one's on one side. I think I did a fairly thorough job of that, but you know what, guys, if you think there's something else I should have checked, down there. I'd love to hear from you all, and I'd love to see you all again on Learning Electronics Repair. Ciao for now, guys.